All right, welcome back, everybody. We got 3.2, solve quadratics by factoring. So in the previous lesson, we learned by square root method, and now we're pushing into the factor method, which has a couple different ways of doing it. So the first learning objective is to solve quadratics by using the factoring method where a is equal to 1 and where it is not, okay? And this is very important because where a is equal to 1 or a does not equal 1, you have a separate set of steps that you need to use, okay? Now, number 2 is use the diamond method to factor the correct factors. This is a method that we use to help us figure out what was multiplied. It's a very important method. And so let's dive into it. So first we have a little bit of math talk, right? Can we go from two binomials back to their trinomials, okay? Now to review that, right, we have a binomial times a binomial, so x plus 2 times x plus 4. We know this is actually a quadratic here that's broken down into its factors. So let's unravel it, right? And you guys know how to do this, right? You take your first, term, you multiply it by the next two, you end up with x squared plus 4x. And then you take 2 times x and 2 times 4, you get plus 2x plus 8. It should all be pretty straightforward. You simplify and you get x squared plus 6x plus 8, okay? So notice how we went from a binomial times a binomial to a trinomial. Those are both the same exact quadratic. There's nothing different about those quadratics, okay? But what we want to do in this lesson is we want to start from this trinomial and go back to the binomial times a binomial, okay? So we're looking at this reverse order. The only difference is we will not have seen these first, okay? And so it often is asking the question a lot, what two terms did we add together to get here, right? What were these numbers equals? All right, so let's dive into that exact example of how do we actually do this. So first, this method is solved by factoring. So the process of finding the expressions that multiplied together to make the quadratic. That's why we call it factoring. We're trying to figure out how to break this trinomial down into the factors that we multiplied to get there, okay? The way we do this is first we identify if it's in standard form, which this is, right? We have an A, B, C. So you have your A value of 1, your B value of 6, your C value of 8. All right, so there's no number there, okay? And then we use the diamond method, or what you're going to hear me call it a lot is the X factor. I just like to call it that way. I don't think anyone else does, okay? And the way we do that is we take our A times C variable up top and our B variable on the bottom. So A is 1, C is 8, so we have an 8 up top. B is 6, okay? And then we ask ourselves a simple question. We go, what number could go here and here that if I multiply them, I get 8. And if I add them, I get 6. So two numbers that multiply to get 8 that add to get 6, okay? So when I look at this, you got to run through the factors, right? Well, I know that 8 times 1 is 8, but 8 plus 1 is 9, so that's not it, right? And then 2 times 4 is 8, and 2 plus 4 is 6. So I know that 2 and 4 go there. Now think about that for a second here. 2 times 4 is 8, 2 times 4 is 6. Well, this trinomial originated from this. And now look at these numbers, 2 and 4. When you did a binomial times a binomial, you had to multiply these numbers together to get 8. And then when they were in their term with x, so 2 times x and x times 4, you had to add them to get your b, right? So you multiply these numbers to get c. You ended up adding those numbers to get b. That's why the x factor is this way. We're asking, what did we multiply to get our c value, and what did we add to get our b value? So this is a reverse order. So now when a is equal to 1, you can jump from this to your answer. You can say x plus 2 times x plus 4. Okay, this would have been it broken down. Okay, now we do need to take it a step further than this though, right? We need to actually find what x is equal to. That is your, quote unquote, your zeros or your x-intercepts. And so we make it equal to 0 and we go x plus 2 times x plus 4. Okay. And now we know something about this, all right? And this is, I think, another cool part about math, all right? If we know that by taking this times this, that my answer is going to be 0, well, then one of those has to be 0, right? When you think about that, because the only thing you can multiply together to get 0 is if one of your factors is 0. You can't go 3 times an actual number that's not 0 and get 0. So let's play, kind of a guessing game. Let's assume one of them is equal to 0 and then find out what the other one is. So let's assume this is 0 first, okay? Which means then we really have 0 is equal to x plus 4. You solve for x, u minus 4, u minus 4. You get x is equal to negative 4, okay? Now let's do it again. Let's assume that this one is 0. So we get x plus 2 is equal to 0. You solve for x. You get x is equal to negative 2. So you have two answers, okay? You have x equals negative 2, and you have x equals negative 4, okay? So this would be going backwards and then finding out what x is equal to, okay? And we do this with the diamond method. Now we're going to do a lot more examples if you're confused at this point, okay? But I want you to understand something. We are trying to go backwards, essentially. You're probably more used to doing this step at this point. This is something you would have seen a lot by now. And you ended up here. Well, how do I go from here back to this? Okay. All right, so we're going to jump into another review because we're going to look at another method of solving by factoring. Okay. We're going to talk about the greatest common factor. Okay. Now, the definition's in the wrong place, okay? All right, so the greatest common factor is the highest number that divides exactly into 2 or more numbers. Now let's look at what that exactly is. Here we have a binomial, 28x squared minus 8, okay? In order to do this, in order to take out the greatest common factor, we look at both terms. We look at this term and this term, and we ask ourselves, what's the biggest number that can come out of both of those? Start by looking at your smaller number. Start by looking at 8, because we can't get any larger than 8. So I know 8 goes into 8, but 28 does not go in, or 8 does not go into 28. So I look at the next biggest number. Look at 4 goes into 8. That's the next biggest. 4 does go into 28. So I'm going to divide 4, which would be our greatest common factor, out of both of these. So 24 divided by 8 is 7. We're left with the x squared minus 8 divided by 4 is 2. And then we would leave this on the outside normally, okay? But if I was just asking what the GCF was, the answer would be 4. Now this is going to be very helpful for the other way, where we don't need to use the diamond method to factor, okay? So let's look at the next one, 16 and 8. Well, I know that 8 goes into both of those, right? 8 goes into 16, 8 goes into 8. I can't get any higher than 8. But I also have a variable in both of them. Now, when you divide out variables, if you remember those properties, you just end up subtracting. If I take x to the power of 3 divided by x to the power of 2, this is the same thing as x to the power of 3 minus 2, or a. So we cannot divide out a larger exponent, okay? And what I mean by that is, for a to the power of 2, we cannot have a greatest common factor that is bigger than that, just like we cannot have a greatest common factor that's bigger than 8, because it's the smallest number. So it's the same thing here, and it's a little bit easier with variables. You can actually just kind of look at the variable and go, well, that's the biggest thing that goes into itself, and that's the biggest thing that goes into a to the power of 3. So our answer here for the greatest common factor would be 8a squared. All right, so I'm going to put that on the outside. We'll call that our GCF, 8a squared, and I divide it out. 16 divided by 8 is 2. And then I do the subtraction, right? A to the power of 3 divided by a to the power of 2 is a to the power of 1. And then a to the power of 2 divided by a to the power of 2, if I were to subtract those exponents, I get 0, so it's gone. 8 divided by 8 is 1, and that's what I would have left. You could see that we kind of factored in a way here. We broke things down into something that we multiplied back together to get to the original. Now, if there's 3 terms, it's the same thing. 3 is my smallest number, and 3 goes into 9, it goes into 27. And then I look, y is my lowest y, right? So that has to be my greatest common factor. Has to be 3y. And then I could divide that out. And I end up with 3y times 9y squared minus y plus 3. Notice how a single y got subtracted out of all of those because we were dividing by y. All right. Now, this is another way kind of factoring with quadratics, and we only really use it in certain situations. This is a situation that I would use this for. Notice how there's no c term, okay? And there's an x in both. So I have my a term and I have my b term. I could use the diamond method here if I wanted to, or I could factor out the greatest common factor and still get to an answer. So look, 4, 16, that's perfect. 4 goes into 4, 4 goes into 16. So I know my GCF is going to have a 4 in it. And then I look at the x. It's the smallest variable, so I know it goes into x squared. So my greatest common factor is 4x. Okay, I'm going to divide this out. Just like that. And I'm going to end up with, let's put the 4x on the outside. 4 divided by 4 is 1. X squared divided by x is just x. And then negative 16 over 4 is minus 4. And there's no more x because they cancel out. And I'm left with this. But this is f of x is equal to that. Now, let's jump back just really quickly here. Let's jump back. When you factored this quadratic, we ended up with x's that were not squared or anything like that, right? Just, a binomial with x and a binomial with x, and we're easily able to set it equal to 0 and find out what x is equal to. Well, if we could do that by simpler methods, why not? Look at here. We have 4x, right, which is a factor, and we have x minus 4, so set it equal to 0. And then again, assume one of those is 0, right? Because that's the only way we could get to 0 with multiplying. So I'm going to assume that this one is 0 first, okay? So that means we have 4x equals 0. Well, you divide by 4, you divide by 4. And so one of your answers is x equals 0. And you're going to see that a lot when you have that monomial there. And then I'm going to do it again, but I'm going to assume 4x is 0. So that means I have x minus 4 is equal to 0. I add 4, I add 4. I get x is 4. 2 answers, okay? Now, we could have done the diamond method, believe it or not. A times c, well, c is 0. You get a 0 on the top, right? And then on the bottom, you end up with a b of negative 16, and you ask yourself, what times what is 0? That gives me 16. And, there's a lot of different things that we could have done there, right? Like negative 16 and 0. You would have gotten to the same answers, but let's not do this, okay? If you see that you can just factor out a greatest common factor, it will be the simplest method. So do that one, okay? All right. So a lot of warm up there, right? A lot of math talk, a lot of just diving into concepts. So let's do some problems, okay? Here we have one where you have x squared minus 9a. I think the next one, the next one's for you guys too. We have x squared minus 9x plus 18, and we're just going to go through. We're going to do this with the diamond method. All right, I see that we have a c term, so we need to do it. We have an a, we have a b, we have a c. We write it out. A times c goes up top, b goes on the bottom. So 1 times 18, or just 18, and negative 9. So I have to ask myself, what two numbers can I multiply to be 18 and then add those to be negative 9? If I try 18 and 1, it doesn't work. Look at this. I know that 6 and 3 give me 18, right? Now, when you look at 6 plus 3, that's positive 9. So that's not correct, right? Because it has to get to negative 9. But I can just make a simple switch, a negative and a negative. Negative 6 times negative 3 is positive 18. Negative 6 plus negative 3 is negative 9. So because a is equal to 1, I can write this out. X minus 6 times x minus 3. Okay? Now we set this equal to 0, and then you cover 1. So x minus 6 is equal to 0 is 1, and x minus 3 is equal to 0 is the other. You add 6, you get x is equal to 6. You add 3, you get x is equal to 3. Boom and boom. Those are your two answers. Okay. Now notice, kind of before I give you one to do, right? You could not have used solve by square root for any of these. Okay. And that's a key idea here. There is a time and a place to use one of these methods. All right. Now here's one for you guys to do. Give it a pause, give it a try. Okay, so hopefully you gave this a try. You do your x factor or your diamond method. A times c goes up top to be 4. B goes on the bottom to be 5. What times what gives you 4? That adds to be 5. The answers would be 4 and 1. 4 plus 1 is 5. 4 times 1 is 4. So I can go 0 is equal to x plus 4 times x plus 1. Okay. All right. Now, I have two equations. Right? I got to set 1 to be 0, so x plus 4 is equal to 0. And then x plus 1 is equal to 0. I minus the 4, I minus the 4, I get x is equal to negative 4. I minus the 1, I minus the 1, I get x is equal to negative 1. So here are my two answers, which are those are your x-intercepts, right? If you were to sketch these, they would need to go through this, okay? All right. So, okay, we're going to start pushing into factoring where a does not equal 1. And this is kind of the beast, all right? In order to do that, we need to review factor by grouping, okay? If you find yourself in a situation where there are 4 terms like this, you can kind of do a double factoring by greatest common factor. And what I mean by that is, I'll jump back to this. All right, this was technically factor by greatest common factor, right? We had 2 terms. We were able to take out the greatest common factor of them. Well, why don't I just do that twice, right? If I have 4, no. If I have 4 terms and I group them, could I do it for each of them? And the answer is that you could. 2x squared plus 8x, the greatest common factor for that is 2x. So I divide out 2 and 2x from each of those. And I would get 2x times, well, 2 divided by 2 cancels to be 1. X squared divided by x is just x. Plus 8 divided by 2 is 4. X divided by x cancels out. You're just left with that. Plus, well, 3x and 12. All right. So the greatest common factor of that is just 3. 3 divided by, or let me put that here, sorry. 3 divided by 3 cancels out. You're just left with x. 12 divided by 3 is 4. Notice something here. These binomials are the same. And because those binomials are the same, we can write them once and take their greatest common factors and write them as the other binomials. Now, you probably are sitting there thinking to yourself, that's crazy. How on earth did you do that? You can't just take 2 binomials and write them as 1 and then put their greatest common factors over there. And the answer is you actually can. You have to remember that when we go from terms written out like this to going back to their factors, that at one point in time you had to distribute. If I take this term, watch this. You're all going to think this is crazy. 2x plus 3 times x plus 4. If I were to write out the distribution, 2x times x, 2x times 4. So if I wrote it out, that's 2x times x plus 4. And then 3 times x and 3 times 4. If I wrote that out, that's 3 times x plus 4, right? Now look at this. Isn't that the same thing? Isn't this the same thing as this? I mean, those are identical, right? So when we find ourselves in this position, we know that 2x plus 3 was really just the first binomial that you multiplied into the second binomial. So we can take those and make our factors, okay? Now, where does this work in when a does not equal 1? So let's dive into that, okay? All right, okay. So here we go, all right? This is going to be a little bit longer, and you got to remember that when you get a problem after this where a is equal to 1, to treat it the way you always did for a is equal to 1. But when a does not equal 1, which you see here, it's a 2, we have to do the factor by grouping in the middle here, okay? So I'm going to go off to the side. we have a times c up top, and we have b on the bottom. Notice how a times c, it was always just a c value before when a is 1, but now we actually get numbers. 2 times 3 is 6, right? Because that was a times c, and then b is 7. So we ask ourselves, what times what gives us 6 that adds to give us 7? The answers would be 6 and 1, okay? Or 1 and 6, either way, okay? Now, what do we do with these? We can't just jump into saying this is x plus 6 times x plus 1 like you would have done where a is equal to 1. Because notice when you multiply these back together, x times x is x squared. Well, we had a 2 here. That's a problem, okay? So we use this to split your bx term. We're going to write this now as 2x squared plus 6x plus 1x plus 3. Now, where did this 6x plus 1x come from? So look at this, 6, 1, 6, 1. Okay, we use these numbers that you just found to split your bx term into 2 terms. And now look, you have 4 terms, which means you can factor by grouping. So group, so there should be a plus in between. It's not multiplication, okay? And then factor out the greatest common factor of each. 2x squared plus 6x, greatest common factor is 2x. So we divide that out. We get 2x times x plus 3. And then 1x and 3, the greatest common factor is just 1. But we still need to do that because we need that extra term. And we end up with x plus 3. Now, quick little tip here, okay? If you don't get x plus 3 and x plus 3, you don't get the same exact binomials here and here, you did something wrong, okay? Now, this order that we did here, 6x plus 1, we could have done 1x plus 6x, and we would still get the same exact answer here. So do not worry about that order. If you do things the correct way, you will get the same one. If you don't, you did the greatest common factor incorrect. Now we're going to take 2x and 1. We're going to write it as a single binomial, and then x plus 3 as a single binomial because we know that this step had to have occurred because of FOIL. All right. Remember, we're going in the opposite order of what it would have been if we did FOIL. Now, this is a quadratic. We're not done. This is equal to 0. So you make your 2 equations. 2x plus 1 is equal to 0, and x plus 3 is equal to 0. All right. And then we solve for x. Minus 1 minus 1. You get 2x equals negative 1. Divide by 2. You get x is equal to negative 1 over 2. Minus 3. You get x is equal to negative 3. These are your 2 answers. Now, arguably much more difficult. Okay. So let's do another one. F of x is equal to 3x squared plus 10x plus 8. Okay. Identify your a, your b, and your c. Make your x factor. A times c goes up top, so we get 24. B goes on the bottom, so we get 10. Okay. Now, what times what gives us 24? That adds to be 10. And when I look at this, let's see what we got here. 6 and 4. Okay, I was thinking like 8 and 3. I was like, why is that not working out? Remember, you're going to be able to find a lot of different numbers that multiply to be 24, but only one that will also fill the bottom condition. So 6 times 4 is 24. 6 plus 4 is 10. So these are the 2 numbers I need to use to split my bx term. So this turns into 6x plus 4x. Or you could have wrote it as 4x plus 6x. How do you decide which to do? I try to look at the other term. 6x and 3x squared are going to have an easy greatest common factor, just like 4x and 8x will. If I did 3x squared and 4x, and then 6x and 8, it just doesn't seem to work as nice to me, but you will get the same exact answer. So I'm going to have 3x squared plus 6x plus 4x plus 8, where then you'll have to factor by grouping. So I'm going to group. I'll make sure to leave that plus sign in the middle. Find the greatest common factor. Greatest common factor, the first one is 3x. So you end up with x plus 2. I'm going to put the 3x on the outside. Okay. The greatest common factor of the next one is 4. So I divide the 4 out. and I end up with x plus 2 again. Good. Don't just make that second one the same binomial if you think you know it, because, when you divide out the greatest common factor, you want to make sure you get that, because if you don't, you did something wrong. And then I combine my greatest common factors in one binomial, and then the same binomial as the other. I set it equal to 0, and I solve. I have 3x plus 4 is equal to 0, and we have x plus 2 is equal to 0. Subtract 4, I get 3x is equal to negative 4. I divide by 3, and I get x is equal to negative 4 over 3. Then here I subtract 2, and I get x is equal to negative 2. So I have two answers, okay? So, no doubt a lot of work when a does not equal 1. Let's go back here for a second. Revisit a problem where a was equal to 1. You didn't have a lot of extra steps. It's a lot easier. You just jump from your diamond factor to solving, essentially. So when you get to these problems, that's got to be the first question you ask yourself. Is a equal to 1? Because if it is, you have shorter steps. If it's not, you got longer steps. Okay? Okay, here's one for you guys to try. Give it a try, and then I'll go over it. Okay, so hopefully you gave that a try. You make your x factor. We have 6 times 4 up top for negative 24. We have negative 5 on the bottom for b. We have to ask ourselves what times what gives us negative 24 that adds to be negative 5. And the answer to that is negative 8 and positive 3. Negative 8 times 3 is negative 24. Negative 8 plus 3 is negative 5. Okay, so we use that to split the bx term. So we get 6x squared. Now I got to choose. I'm going to put the 3 first because I want to do the greatest common factor with 6 and 3 and then with 4 and 8. So I'm going to go plus 3x and then look, minus 8x. Notice how that negative made it in there? Minus 4. Ooh, I like this one. Then I'm going to factor by grouping. And I'm going to put a plus here. Okay. I'm going to divide out the greatest common factor, which is 3x. And so I get 3x times 2x plus 1. And then notice something here. There's a negative in both of these. And sometimes you have to make that decision. Do I take the negative out or do I not? Watch what happens when I don't. Let's just say I say greatest common factor is 4. Well, then I would end up with negative 2x plus 1. Nope, minus 1. Notice how that's the exact opposite values of 2x plus 1. So we do need to take out that negative. So we should make this a negative 4 greatest common factor. And then we end up with 2x plus 1. We write the greatest common factors as one binomial, and then the other one as 1. Okay, we set it equal to 0. We get our two equations. 3x minus 4 is equal to 0. 2x plus 1 is equal to 0. Add 4. We get 3x equals 4. You divide by 3, and you should get x is equal to 4 over 3. And then here, minus 1, you get 2x equals negative 1. You divide by 2, x is equal to negative 1/2. That's your other answer. Okay, a little bit longer, that's okay. All right, finally made it to the end. What method and when? Okay, a little bit of math talk here. All right, you now know two methods. You know, solve by square root, you know, by factoring. Here's a couple examples. All right, if you see this. All right, let me get some red going here. So if you see a missing bx, okay, then solve by square root. Very important. Missing bx, and also if you see something in vertex form. Vertex forms are really good solve by square root, okay? Now we could convert vertex form to standard form, but why? Just solve by square root, okay? Now the next one is, what if you have this? F of x equals, let's do, 3x squared plus 6x. Now you could do the diamond method, but notice how there's a missing c value, and you have a missing c value, and you have greatest common factor. So you want to solve it's solved by factoring, but you're not using the diamond method. You're going to use the GCF. Okay. Next one. If you have a trinomial, so like an x squared plus 3x plus 4, something like this, okay, then that's where you're going to solve by factoring. And you're going to use the diamond method to do that. Now remember, if a is equal to 1, it's very easy. If a does not equal 1, you got to sprinkle in a little bit of solve by grouping in the middle. Okay. Now lastly, let's just say you have an x factor, and let's make the top number 8 and the bottom number 7. Okay. And you start to look at this and you go, okay, well, 8 and -1 multiply together. Well, they don't actually multiply together to give you 8. They multiply together to give you -8. Okay. So why don't I do 8 times a +1? Well, 8 times +1 gives you 8, but 8 plus 1 is 9. And that's where you might want to try the -1, because 8 minus 1 is 7, but 8 times -1 is -8. Notice how we're not getting anywhere with this. 2 times 4 gives us 8, but 2 plus 4 is 6. If you get to this situation where there is no possible way to go forward, all right, then you are going to need to, then this is a situation where solve by factoring does not work. And I'm going to add does not work easily. There is a number there. You're just not going to like what that number is, and you're not going to be able to figure it out, just in your head, okay? That's a situation where we would use our third method that you're going to learn in 3.3, solve by quadratic formula, okay? So I hope this helps, all right? And, good luck. This is a super long lesson. I'm just going to end the video. Good luck, everyone.